Thanks for joining today's session and a very warm welcome to all of you. Our panel discussion for today is investigating the pros and cons of operational machine learning. And we have two phenomenal speakers today, Chathuri Daluwatte and Carolyn Phillips. Let's get started. Before we get started, a quick introduction about myself. I'm Neha Borkar and I work in product analytics and data science team at Adobe. I'll be moderating today's session. Let's start with a quick round of introductions of our panelists. Let's start with Caroline Phillips.
Hi, everybody. I am a senior staff machine learning scientist at Wayfair. I am a computational physicist turned data scientist turned machine learning scientist. I would say that my passion is getting machine learning science research deployed into engineering production systems at scale and making it easier for a team of very smart data scientists to support their whole model life cycles.
Thanks, Caroline. Chathuri?
Hi, everybody. So I think there's a mixture of where my organization is from. So since recently I worked as the head of MLOps at Sanofi, but since then I have transitioned to a new role in Alexian AstraZeneca as head of AI and digital diagnostics. From my background, I am trained as an engineer as well as a scientist through 3 degrees, and just like Caroline, I am also very interested in bringing machine learning to non-data scientists or the business people so that we can actually realize the value to the business or the patients or the healthcare providers through machine learning.
Thanks both. So let's get started with a few questions. We would like to know what are the main benefits of using operational machine learning for an organization and how can it improve business outcomes? Maybe Caroline, can you take that question?
Uh, sure. Um, I think in the end, if you need to do fast, scalable decision making that can take into account hundreds of pieces of information and can weigh the relative value of those hundreds of pieces of information, and you need it to even adapt over time to how the relative value of that information can change, that's where you need to basically have kind of an operational machine learning um, in your business organization. What's interesting is, like, I also find there to be a lot of value in thinking about when you don't want a machine learning operation in your business. So if you take that phrase, fast, scalable, that can take into account hundreds of pieces of information, adapt over time, if like any of those phrases, it's like, no, slow is fine. Very small decisions, don't, very tiny amount of information, and we don't even want that. We don't even care. We don't even think the decision we would make would change over time. Like, that starts to tell you when you get to the other end, and when you start to think about, well, let's not invest in putting a machine learning operation. However, I think in the modern business, like, we've got tons and tons and tons of situations that look like that needed fast, scalable, large decisions, taking into account lots of information. There's no shortage of those, and I, so if you can segregate out like the where you should be putting it and where you don't need to be putting it, there's just a lot of work to be done.
Thanks, Caroline. My next question, what are some common challenges that organizations face when implementing operational machine learning and how can they overcome them? Chathuri?
Yeah, I can take that one. So I think the main benefit for using machine learning in an organization is businesses run on data. So every day businesses collect a lot of data, and during the digital age today, there's more and more data generated just about the business, and then decisions need to be made around this this like using this data instead of opinion driven decisions. And in order to do that, that's where we need the machine learning operations. However, the challenges also lies in that aspect of the data part. So there's a lot of challenges when you're implementing an MLOps system around, okay, what are the data that are important to the organizational business decision making, and how are they coming, and how can we make sure those are available to machine learning, especially for an MLOps practice. So data is one of the big things. And then the second thing is there's a major difference between machine learning operations, operationalizing a machine learning versus just doing machine learning on a notebook. So when you're doing machine learning, it's really important. It's just one step complex than deploying a software. uh, so you have to do all the things that you do for a software, like version controlling, CI/CD, things like that. But on top of it, now you have to also manage the life cycle of your data and manage the life cycle of your model, and make sure all those three things are connected the right way, and they continue to are connected the right way, because you can have a drift in your data, and your model may not be predicting the way, and it's not behaving the way it's supposed, and you may be making wrong decisions because you have a data drift now. So any setting infrastructure for all of that is one thing. And then the other thing is you're now using, like, you have computers giving decisions to humans, making sure the humans are capable of digesting this information and making the next step of decisions using what's outputted from the model. So adoption by the business users or non-data scientist users to use this machine learning is another common challenge. So there are like a lot of technical pieces to do it. And then within the data science practice itself, data science is taught today a lot using notebooks, and changing that mindset from notebook to, okay, you have to do this like a software and using version control, CI/CD. There's a big change, and just pushing data scientists from that notebook mindset to MLOps practice is a challenge itself, just within the core community of MLOps.
Yeah.
If I could add to that, I think in order to deploy a model, like, you have to get everything else right before you can even get to the point where you're deploying a model. Like, your infrastructure has to be stable. You have to have good data governance. You have to have generally like a strong, solid way of deploying things into production in like tested ways. And then you can start to think about all the challenges of how you put into place a model where that can quietly give you garbage if stuff is going wrong. I mean, I think the really hard thing about a model system is that when your model system is degrading and behaving badly, it's not like, throwing errors, it's not shutting down, it's just slowly giving you crap. And you have to figure out how do you, so when you have all that other stuff in place, then you have to start to think about the specific extra challenges of how you keep a model giving you quality, valuable business value adding outputs, and all the extra things you have to put around a model to keep it going. So if your company hasn't yet really mastered how to have a strong production deployment system, how to have strong governance, you're just layering more things going wrong on top of things going wrong to try to also then figure out a model deployment.
Yeah. However, in the reality of things, like, it's never possible to have everything perfect and all these dots aligned. So, and then also, like, the life cycle of technology changes is much faster nowadays. So even if you set up the perfect system, it takes years to set up the perfect system. By the time you finish setting up the perfect system, okay, technology is outdated, you have to change it. So you have to be agile. So there's never a way, okay, I'll perfectly do this then do MLOps. So it's an agile act, and you have to act with the maximum amount of agility.
I mean, I've certainly seen cases where our model monitoring was sufficiently more mature that we were actually catching like upstream, like in the degradation of our model signal, we were actually catching like data quality getting messed up upstream, and you're like, okay, you should have, we should be having the kind of checks upstream to catch that stuff, and the model monitoring should be about the model monitoring. But hey, at least we caught it because the model monitoring was really sensitive. So it is, you work with what you have, you deploy with what you have, but it's there's a lot of stuff that has to go right for everything to like really work.
Thanks, Carolyn and Chathuri. Yeah, I agree with Chathuri that we need a big shift in mindset, to actually move to MLOps. Next question. How do MLOps differ from traditional machine learning approaches, and in what situations is it most suitable? Carolyn?
Sure. I think, Chathuri, you kind of alluded to this earlier, that when I think of like what we think of as like, the real basic machine learning activity, um, there's this kind of like idealistic perfection about it. You get your data, you groom your data, you break it up, you build your model, you validate your model, you test, you iterate, and there's this, you can do this in a really small team, maybe even just one person, but then you take that like ideal model and that ideal data, um, and you plop it into the middle of this real world noisy situation where maybe you can't get the data fast enough into the model. Maybe the infrastructure that you're trying to serve the model on is a little flaky and goes down a lot. Maybe you're worried about how that data might be shifting over time. Like it's like you have to, and again, it kind of comes back, you have to have the basics of building a model right. But then you have to figure out how to make that model be robust and like have a engineering around that model that can work in a never going to quite be perfect. Something is not going to be able to show up on time. The model calculation is going to be very accurate, but take too long to actually, deliver the prediction when it needs to. It's just the how do you send this baby off to the real world and have it be able to like navigate and work in a real system.
Yeah, I think one of the main things to differentiate between traditional machine learning approaches and MLOps is that MLOps is a team sport. Traditional machine learning, you can just get the data set, you can have a notebook, and one data scientist may be able to deliver it. But MLOps, it's a team sport. There's no way one person can deliver it, so it has to be different teams handling the different parts of it and working closely together so that you're passing your ball or whatever the team sport you're imagining when I say a team sport the right way, so you have the right handoffs and right handshakes. So like that team sport aspect is really really important for MLOps just as much as the technology, because technology is built by humans, are built for humans. So a lot of times in these discussions we forget the human part, but that is really really critical.
Thanks, both of you. Um, my next question here is, what are the ethical considerations associated with operational machine learning, and how can organizations ensure responsible use of these models?
So
Chatu?
I think like in terms of ethical considerations, definitely there's general ethical considerations around machine learning. So when you're training your models, that you make sure that it has the right diversity, so that it's not predicting wrong things for a wrong demographic, or that we have the right data coverage and we know the blind spots and it's not used in an unintended sequence in consequences. And also I think it's also really important, we are now building this digital brain, so we don't bring our real world biases and have it coded into our system. So watching for that, like sometimes we can correct it, even if we can correct it knowing that okay, we have this bias in this system, so do not use it for this, or watching out for that is really important in terms of the ethical considerations of machine learning.
I think I would add, like, ethics and machine learning is a whole big topic, and there's a lot of, we understand now that if there's bias in your data, then your model will learn bias. And, a lot of that sort of falls into we have to think about the design of the product. We have to think about the design of how it fits into our system and who our users are. And we have to think about where our data is coming from. A lot of that kind of falls into the traditional, thinking about ethics and machine learning. I would say if there's any special ethics consideration that kind of goes hand in hand with MLOps, I think it's thinking about when all systems fail, models fail, like they can't give an answer. They, this situation we can't handle and we have to punt it. There's always like little like parts of the space that you fundamentally are like, yeah, we can't really address that. And when you think about who is that? Who is the user coming in who's being put into your model, and you're saying, we're going to, we can't handle this kind of input, and so we're going to, punt over to a default solution. And I guess, like, I think there's some real world considerations there. Like, I think of it in terms of like, like, is it names? Is it demographics? Is it regions of the country? Is it like, are you being discriminatory in who you're considering we will absolutely cover these situations versus who you're like saying, yeah, we can't really handle that.
Yeah, I agree. All right, moving on to the next question. How is the field of operational machine learning evolving, and what new developments can we expect in the future?
I think the field of machine learning operations is exploding right now. There's a new startup I see every day that develop a new platform to do MLOps, I was just coming to the talk before this, and I thought it looked like Databricks, and I thought it's a different company, but it's Databricks and then another company together. So there's a lot of gaps in MLOps, and there's a lot of innovation going on to make that easier. And so it's a really evolving field, and this is why I said the previous comment on you cannot build your perfect system, because the system and the system thinking and all this is still evolving, and it's a hotbed of innovation. And I think there will be more and more to come. But another thing is, like, so we already talked about it, there are a lot of pieces that need to work together to have a seamless, smooth MLOps experience. But then, like, okay, so many buttons to turn. So one of the aspects is like, okay, how can we increase the developer productivity to connect all this in a more smoother way, so that like we all are not like constantly fighting fires. So I think there's a lot of innovation in that space as well, not just platform engineering, but how do you make that experience uh, seamless and smoother and increase developer productivity. And then I think the something to expect in the future is machine learning being used to improve MLOps is a big one. Like, I'm sure there's like code, like GitHub Copilot, like things like that that will help writing codes or write codes on it on your own. Like, you can write the story in your natural language, and behind the scene it'll build the model for you. So low code apps, app development. So I think those are the innovations to expect in the future in this field.
I think that one thing that has changed is that we've been raising the bar on what we expect data scientists to know. The amount of engineering skills, and I would say we still understand, or at least in my job, we've understood that if you're coming straight out of college, coming straight out of a graduate degree, of course that generally was not the ideal place to, have well-developed software engineering skills. But I think we are emphasizing much earlier in someone's career that, you have to like learn these best practices. You have to adopt GitHub in a way. You can't just do whatever you need to you know think about CI/CD and start integrating that in right away. And and we need to make sure that we have people who can teach you and who can help you and mentor you. But we will expect that in order to be productive, that you're going to master these skills sooner. I also think that we saw this, like, I'd say, democratic revolution of machine learning platforms, to the point where anybody could build a model. It might not be the right model, but anybody can build a model. But the problem is that didn't mean it was easy to deploy the model. Like the speed at which you could learn to build a machine learning model, and the speed at which you could learn how to implement, smartly integrate a machine learning model into a system, these things weren't keeping up with each other. But I feel like every year that's a push button now. You could deploy it by just adding this hook in this system, and it'll automatically go here and it'll show up there. Like, I feel like every year, things that were really challenging and hard, all of a sudden there's something that makes it easy for you. But as a person working in the field, you have to, like, either if you're a certain level, I got to keep on top. I can never be like, that's cool, I don't want to learn that. No, you have to keep on top of those things. And if you're at another position in the field, you have to be thinking, what is the next open source thing or platform, a thing that we need to be bringing in, so we're not the company that's struggling with manually shoving these things through, while that company over there is going boop and it's just already up in the cloud.
Thanks, Carolyn. Thanks, Chathuri. Since MLOps is an exploding field, we would like to know what steps and qualifications are required for an advancement in a career path focused on MLOps.
So I think like Caroline touched on that in her previous comment a little bit as well. So uh, machine learning itself is a combination of multiple things. Like, you need to know mathematics, statistics, and you're solving a problem in the business domain. So you may need to know the the business or the domain, and the depth of it you may need to go deeper. For example, I work in life sciences and I have worked in different modalities. So if I'm doing cardiovascular ECG, I need to know everything about ECG, to the point I cannot just throw ECG data into a machine learning model. I need to know what it is about. So like that, you need to go know that. And then also, uh, and then when you go from and then definitely coding, even if you just do machine learning. But if you're doing ML ops, it's not just coding, writing code. You have to write codes in a very disciplined way. So learning and knowing those software engineering best practices, computer science fundamentals, and like algorithms, data structures, etc. And then you need to know a lot about the data engineering, how, efficiency, how to optimize things, and that's there. And then also the ops part of it, like version control, CI/CD, then the monitoring piece of it. So there's like a lot of these pieces. You don't have to know everything to like actually deploy a model. So like, to know version control, you can be quite effective knowing 4 Git codes. That's all you need to know. But more you know, you'll make it more seamless. Your life will be easier. So there's a lot of things. So if you go in that direction to learn, these are the things fundamentally. But then in MLOps, you're actually building a bigger product. So there's definitely pieces of software project management and project delivery, like agile. How are you working with the rest of your team? How do you manage your own work, so you know, okay, this is the thing I want to do today, and how you manage it, how you communicate. And then there's also this element of design thinking, and how you're designing what you're going to develop, and then how to communicate it to the users and get your users feedback to know what you have to build. So these are all the things that you can learn to advance your career, and more of these skill sets you have in your toolbox, more desirable you are as a candidate if I'm hiring. So I think those are there's like the list of things you can learn to advance career in this field is like uh it's endless.
I think the thing that's kind of exciting is that there isn't this like rigid trajectory of how one gets into MLOps. It's like way too young for that. It's lovely when people ask a question like, "How can I get a degree in MLOps?" And you're like, "Well, that's great. This field basically came into existence in the last 5 years. I promise you, there's not. I'm probably wrong. There probably is some university out there that has a degree in it, but suffice to say, most people in the field ended up in it because that's where the problems were in their business, in their work. So I think there's a lot of there's so much to learn and figure out, and you just have to be like someone who just likes to own the next phase of a problem. Like, why are we having so much trouble here? Who's doing this best? How can we go learn from the software engineering community how to bring over the things that they do that we like the best? How come this is hard? Why can't we build a better way to do that? Is there a better tool out there? And if you're like just constantly trying to solve these problems, you'll turn around and you'll be like, wow, I talk with data engineers and I talk with my product owner and I know what really matters to the data scientists and what they care about in their data, and I understand how we should use this. And you kind of just like, as the problems arise and you try to think, whole design decision making, you just find yourself acquiring new skills, and all of a sudden you realize that people say that you do MLOps, and you think, well, I just kind of got there by chasing the problems and learning as I went.
Yeah. And also, if that's not enough, there's also this whole ethical legal piece to MLOps that coming into play now. So it's going to have an arc very similar to what GDPR had. Like, so a couple of years ago, European Union launched this data governance law, GDPR, and then China came up with their version of GDPR. US hasn't come with a similar one, but it's coming. But then this year, Europe again deployed the AI Act. So there's all this legal compliance aspect to AI, and the rest of the countries will also follow. So like even if you know all the technical pieces, there's also these other pieces that you need to be aware of if you're working in that field.
Correct. Thanks, Carolyn. Thanks, Chathuri. My next question is, how does the deployment of operational machine learning impact on the organization's infrastructure, and what steps must be taken to ensure the seamless integration?
I think so. Like managing the infrastructure for MLOps is a big piece, and it's a big strategic goal any organization should have. And I'm sure that we have recent examples from the aviation industry, for example, about ignoring the technical debt. So it's gonna be an order of magnitude larger for MLOps, because it's not just you cannot access the system, it can be you're making totally wrong decisions and your sales and profits, etc., are impacted, or you may be making something illegal, or there's compliance risk around it. So platform engineering and this enabling that for the organization, I think, is going to be a really critical important component for any organization if they want to be relevant in today's current market, and especially if you're putting machine learning models into production. And so it's a game on its own. You have to be on top of it, and like being on top of by deploying models is one thing, but enabling that infrastructure to the developer community within the organization is a field of its own, called platform engineering after I think 3 iterations. um, yeah, so organizations should start thinking about it and start investing it, because otherwise the world is just going to pass by.
I'm trying to think about this phrase, an organization's infrastructure. Definitely one impact trying to work with machine learning on an organization's infrastructure is that data scientists are going to ask for all kinds of crazy things. They're going to want GPUs. They're going to want massive memory. They're going to want all kinds of like interesting new architectures. And you are going to have to think about, you know, how do we, these are the big obvious benefits of being in the cloud is you can be like, no problem, we can spin you up some special architecture to try out a new solution. And if it's worth it, you know, we can think about putting that special infrastructure into a production system if it's really valuable. Of course, then you might have some, you know, really, really expensive, highly specialized computing system in the middle of your production system. And then you might need to think, is the cost, you know, is the cost of that worth the slight extra bit of accuracy that we get for that? I think another thing about seamless integration is I feel like you really need to think about the guardrails that you put around a machine learning system. Both operationally, we think about that kind of thing all the time. What happens if this system doesn't give a response back? But also in the case of a model, you know, what happens if it returns, you know, 10 to the 7th? What happens if it accidentally divided by 0? You know, what if it returns not a number? What if it, how do I, you know, keep like really crazy results from, like, how do I put like numerical guardrails and decision guardrails and things, just because I need to make sure models can do crazy things. You can't, it's hard to test every corner case that a model will see and be absolutely sure what it will do.
Thank you both. My last question, since we have less than 5 minutes, how do we take care of data governance in MLOps? Like, I know we have this whole thing called data governance in ML, and how do we take care of that in MLOps?
I think, yeah, I'll go first on this one, and you can jump in, Chathuri. I think the biggest, you know, thing that we worry about is how to make sure the live data matches the training data. And that's a very difficult challenge. And that's where you need a lot of governance. What's your thoughts, Chathuri?
Yeah, I agree. I think like one of the things is the first piece is monitoring, right? You cannot just train a model, okay, it's great, and just throw it out there and assume that it's going to be always correct. So putting that data monitoring piece around your ops machine learning is the first piece. So you know if something is going wrong, you know. And then now you know, oh, the the most important thing is if something is going wrong, then you have to go back to your data architecture and fix it there, because no matter what you change in your MLOps stack, it's not going to solve it, because it needs to be solved up front. So you have to go to your data architecture piece and fix it there whenever you catch it. That's the most sustainable way, because fixing it downstream, it's very short term fix, and you may leave another day, but then you'll be at again of the problem. So if you're monitoring something is drifting, it's 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 always systematic. So go back to the system and either fix it in the data system or retrain the model and deploy the new model, or think about implementing real-time model training and the guardrails to make sure it's another beast on its own. So these are the data governance pieces that you need to think when you go to MLOps.
I think this was really fundamental, but I find data scientists are very resourceful people. They want to solve the problem. And I find very often they find problems in the data and they write fixes for it.
Yeah.
And you say, look, that's, like you said, that's short-term thinking. It's great that you wrote a one-time bespoke fix, you know, that will automatically, when I see this condition, you know, impute this. I'm like, you need to push these things upstream. You need to let the team that owns that data stream be responsible for the quality of that data, not just be like, whatever, I'll just fix it when it comes in. It looks a little wrong.
Yeah.
All right. Yeah. Thanks, Caroline. Thanks, Chathuri. This has been a wonderful panel discussion, and I think we are almost about time. Thanks for giving your time and giving us valuable inputs regarding MLOps. And I'm sure it's a very valuable input for all of us going forward. Thanks for your time.
Thanks, Neha, for doing a great job moderating the panel.
Thank
Thanks for giving us an opportunity to reflect on what we've learned.
Yeah. Thanks, Rework, for the opportunity.